Bismillahirrahmanirrahim. Dear students, today we will discuss adsorption phenomena in physical pharmacy. As up till now, we have discussed solubility in our physical lectures. After solubility, the next topic is adsorption. So let's start, student. We will discuss what is adsorption. First of all, let's start with the definition. Adsorption is a mass transfer process which involves the accumulation of substances at the interface of two phases such as liquid-liquid, gas-liquid, gas-solid or liquid-solid interface. Or we can also define it as addition of atoms, ions or molecules from a gas, liquid or dissolved solid to a surface. As you can see here in the picture, let me enlarge it. There are few terms in the diagram under the heading of adsorption. This is the outer side. This is the adsorbent, the substance which is going to be adsorbed. That is called adsorbent. And this is the surface which is used for adsorption. The surface that is used for adsorption is called adsorbent. This is the inner side of the solution. From solution, actually we used to adsorb substances on a adsorbent. So we have discussed it physically in classes. So let's repeat it once again. As I have told you, adsorption means that you are going to add something on a surface within two phases. Of the interface of the two phases, we are going to adsorb substances. There are few important terms that you must need to know in the topic of adsorption. Number one is adsorbate. Adsorbate, the substance that is adsorbed on the surface is called adsorbate. Means those substances which you are going to adsorb at a surface will be called as adsorbate. And the next thing is adsorbent. What is adsorbent? Adsorbent, the surface of the substance on which adsorbate is adsorbed is called adsorbent. Means there are two things. One things which you are going to adsorb and the other on the surface of which you are going to adsorb. So the surface which is used is called adsorbent and the substance which is going to adsorb is called adsorbate. Hope it will be clear as we proceed further. Desorption. Next term is desorption. Desorption is the opposite of adsorption. The removal of adsorbate from the surface of adsorbent is called desorption. Means it is opposite of the adsorption. Absorption. Students, you must have a clear idea and difference between the absorption and adsorption. Absorption is the penetration of one component throughout the body of other component. This phenomenon is called absorption. Means the molecule will penetrate in the other molecule, while in adsorption molecules are simply added on the surface. There is no penetration in the adsorption phenomena, while absorption requires penetration of one component throughout the other component. Next term is sorption. S-O-R-P-T-I-O-N, sorption. When there is not any distinction between adsorption and absorption, the word sorption is used. Means if we are not clear that what either it is going to be adsorbed or absorbed, then we generally use the term sorption. Let's proceed further. Now, principle of adsorption means driving force for adsorption. As we know that adsorption is a surface phenomena, and as a consequence of surface free energy, means adsorption occurs due to the surface free energy, the energy which is present in the surface and responsible for the phenomena of adsorption. The surface of liquid or solid is in a state of strain or unsaturation, which results in an unbalanced residual forces at the surface. These unbalanced residual forces result in higher surface energy. Consequently, the surface of liquids, solids always have tendency to react and retain the molecular species with which it comes in contact. This tendency is responsible for the phenomena of adsorption. Means adsorption is a surface phenomena. Surface phenomena, by surface phenomena, we means that it will occur at the surface or it will occur at the interface of the two phases. As we know that if we talk about that what is surface energy, by surface energy we simply means that the energy which is present in the system and will responsible for the work done. As you know that if we consider a liquid medium, that all the molecules in the liquid uh, have balanced forces around itself. Only the molecules that are present at the surface have unequal forces, and we call that is a surface tension. So surface tension is also a form of free energy, means there is a force which is responsible for a work done. Let's proceed further. Adsorption is spontaneous process. Spontaneous process means absorption will occur by itself. It will not require any input of energy. So if we will discuss the spontaneity and exothermicity, exothermicity means that adsorption is an exothermic process. Spontaneity means that it will occur by itself. We will not add any energy into the system. Any process can be represented thermodynamically under constant temperature and pressure by Gibbs equation. Gibbs equation is delta G is equal to delta H minus T delta S, where delta G is Gibbs free energy, delta H enthalpy or heat content of the system, T is temperature, delta S entropy of the system. The process of adsorption is spontaneous. Therefore, delta G is equal to delta H minus T delta S is less than 0. Because we are not adding any energy into the system, it will occur by itself. So less than 0 means it is negative at constant pressure and temperature. As the transitional freedom of the adsorbent is reduced when it is adsorbed at the surface of adsorbent, thus delta S is also less than 0 or negative. Therefore, the equation becomes delta G is equal to delta H plus delta Ts. If we will put negative sign with delta S, negative, negative, when negative sign multiply with negative, it will result in positive. So the final equation is delta G is equal to delta H plus T delta S. From this equation, we can conclude that adsorption phenomena is spontaneous and exothermic. Let's proceed on the next slide. For spontaneous process, delta G is equal to 0, less than 0, and hence delta H should be negative. Delta H is also less than 0, delta G less than 0, spontaneous, delta H less than 0, exothermic. Hence, adsorption is spontaneous and exothermic process. Let's proceed further. Now we will discuss types of adsorption. We have covered all these topics in physical classes, but I want to repeat it before proceeding further. As we have discussed in our physical classes, types of adsorption. First one is physical adsorption. By physical adsorption, we means that when we are going to add a substance on an adsorbent, the addition will occur through van der Waals forces, that is weak intermolecular forces will be responsible for the adsorption of adsorbate on the adsorbent surface. Example is adsorption of toxin by kaolin. Next is chemical adsorption. By chemical adsorption, we means that valence forces, that is covalent bond or ionic bond, will be responsible for the addition of adsorbate on the surface of adsorbent. Means the interaction between the adsorbate and the adsorbent will be a chemical bond. Valence forces means chemical bonds. Examples are adsorption of strychnine HCl on the activated charcoal. There are also positive adsorption and negative adsorption. What do we mean by positive and negative adsorption? Simply, if the surface concentration of adsorbate is greater than its concentration in bulk volume, is called positive adsorption. Means that the molecules that are present on the surface of the adsorbate are greater than the molecules that are present in bulk volume, from where the adsorbate is coming and adding on the surface of the adsorbate. So by positive adsorption, we will mean that the molecules that are present at the surface of the adsorbent is greater than those molecules that are present in bulk volume. While by negative adsorption, we mean that the concentration of adsorbate, means the substance which is going to be added, is greater in bulk volume than the surface, is called negative adsorption. Means the concentration of adsorbate is greater in bulk volume and less on the surface of the adsorbate. This type of adsorption will be called as negative adsorption. Let's proceed further. Now, factors affecting adsorption. This is the current topic. Up in physical classes, we had discussed it up to the types of adsorption. Now, let's start with the factors that affecting the process of adsorption. The first thing is solubility of the adsorbate. The adsorbate, as we have discussed, is the substance which is going to be added on the surface. As far as solubility and the relation of adsorbent adsorption phenomena, so adsorption is inversely proportional to the solubility of the adsorbate, because increased solubility will result in strong interaction of solute and solvent, and that will retard the process of adsorption. This rule is called Liouville rule. Simply, solubility is inversely proportional to the phenomena of adsorption. As we know that by solubility, we means that there is an interaction between the solute and solvent molecule. And if that interaction is strong, means the solubility is greater, the interaction will be strong. So they will hold the molecules of the adsorbent and will retard the process of adsorption. Adsorption of hydrophobic is more than hydrophilic substances. Hydrophobic means water repelling substances and hydrophilic means water loving substances. If adsorption is more in hydrophobic substances, because if water is a solvent, then there will be no interaction between hydrophilic and hydrophobic substance, and there will be no strong interaction between the solute and solvent molecules, and it will facilitate the process of adsorption. Next is increase hydrocarbon chain will increase adsorption if the hydrophilic part remains constant. Suppose there is a molecule, there is a hydrocarbon, and if we will increase the chain of hydrocarbon, as we have discussed earlier in solubility, that increase in chain of the hydrocarbon will decrease the hydrophilic or polar character. So with the decrease in polar character, adsorption phenomena will increase. So first factor that affect adsorption was the solubility. If we can say that solubility is inversely proportional to the phenomena of adsorption, and the logic is because if the substance is more soluble, it will have a strong interaction with the solvent molecule, and the solvent molecule will not let it go to the surface of the adsorbent. So the process of adsorbent will be less. The process of adsorption will be less. So therefore, we can say that simply adsorption is inversely proportional to the solubility of the adsorbate. Next factors that affect the adsorption phenomena is pH. pH, as we know that pH is the hydrogen ion concentration, and we know that ionization is affected by pH, which affect the solubility of the drug. The process of adsorption is inversely proportional to the ionization, and maximum when the drug is completely unionized. It means that solubility is inversely proportional to ionization. Means if ionization is, there is no ionization, there will be no solubility. If there is higher ionization, then there will be a solubility. So we can increase adsorption phenomena if we will suppress the ionization of the substance. The adsorption is maximum at isoelectric point in case of amphoteric compounds. Examples are adsorption of hyoscine and atropine on magnesium trisilicate. Hyoscine is completely unionized, then atropine, which is 50% ionized. Even then, atropine is more adsorbed than hyoscine because hyoscine is more soluble than atropine. So hope it is clear from the example that ionization is also inversely proportional to the adsorption phenomena. If we will suppress the ionization, then adsorption will increase. The example is the adsorption of hyoscine and atropine on magnesium trisilicate. Hyoscine is completely unionized than atropine, which is 50% ionized. Even then, atropine is more adsorbed. Because why atropine is more absorbed? Because hyoscine is more soluble. So in the in the above factor, we have discussed that solubility is inversely proportional to the adsorption. So if hyoscine is more soluble, then it will retard adsorption phenomena. Let's proceed further. Next is nature of the adsorbent. Increased surface area will increase adsorption, because surface area increase with the decrease in particle size, because more vacant sites will be provided by decreasing particle size. As we decrease the particle size, we know that we are creating new surfaces. Therefore, surface area increase, adsorption phenomena will be increased. Examples are activated charcoal is prepared by removing the surface impurities to convert it into small particles, and is prepared from coconut shells. So nature of adsorbent, by nature of adsorbent, we means that we are considering the surface area. Surface area increase with decrease in the particle size, and if the surface area will increase, it will increase the process of adsorption. Next factor is temperature. As adsorption is exothermic process, therefore increase in temperature will decrease adsorption. Simple, it is simple. Hope it is clear. Let's proceed further. Factors affecting adsorption: pressure. This is important. Pressure at solid gas interface. Solid gas means you are going to adsorb gas at a surface of a solid adsorbent. At solid gas interface, the number of moles, grams or milliliters of X gas adsorbed on m gram of the adsorbent at STP is given by amount adsorbed is equal to X upon m. We take this factor on y-axis, if you can see in the graph. With increase in pressure, the adsorption increases with increase in pressure up to the saturation point. After that, there is no effect of pressure on the adsorption. X upon m is equal to Kpn, where K and N are constant and depend on both the nature of adsorbent and absorbent. P is pressure, means up to certain limit, adsorption at solid gas interface is directly proportional to the pressure. Then at certain point, when all the adsorbent surface is saturated with the gas, then no further adsorption will occur, and the process, as you can see from the graph, is constant, means there is no adsorption taking place. The graph between the amounts of adsorbate X adsorbed on the surface of adsorbent M and pressure at constant temperature. Xm is the amount adsorbed per gram of the adsorbent, which is obtained by dividing the amount of adsorbate X by the weight of adsorbent. Let me explain this from the graph. You can see here on y-axis, we have taken the loading. This is the loading phenomena. And on x-axis, we have taken the pressure. As you can see that as we increase pressure, loading is increase. There, then at a point, at this point, this is called saturation pressure, means there is no further vacant space on the adsorbent surface. So no gas molecule will add it, and you can see that from here, the process becomes constant. So we can say that adsorption is at solid gas interface, adsorption is directly proportional to the applied pressure up to a certain limit, and that limit is called saturation pressure. After that, the process becomes constant. Adsorption phenomena is usually explained by isotherms. Isotherms are like this. This is also isotherms, means at constant temperature we can study the phenomena of adsorption. Hope it is clear up till now the effect of pressure on the adsorption phenomena at solid gas interface. Now let's proceed further. Next factor is concentration. At solid liquid interface, the adsorption depends on the concentration of adsorbate. That is, more the adsorbate, more will be the adsorption phenomena. Amount adsorbed X upon M is equal to KCN, where K and N are constant and also depends on the nature of both adsorbent and adsorbate. Let's proceed further. Now, students, let's start with the examples. Commercial adsorbent that are available in markets are, I have noted few of them. Silica gel. The first one is silica gel. It is used for the drying of organic solvents, and you can also use it in different types of medical packages. Like we use it in small bags in medicine packs too, for those drugs which are hygroscopic in nature, that absorb moisture from the surface. So we put a silica gel bag to protect it from the effect of moisture. The next is activated alumina. It is used for drying of organic solvents and gases. Activated carbon, it is used for the removal of odors from gas, recovery of solvent vapors, nitrogen from air, and in purification of water. Polymers and resins. It is used for the purification of water, recovery and purification of steroids and amino acids, separation of fatty acids from water, and toluene, recovery of protein and enzymes. These polymers and resins are used for the following purposes. Let's proceed further. Clays. Clays used for the refining of mineral oil and edible oil. Clays are used for their purification or refining. Zeolites. Zeolites are microporous, means containing small pores in their structure, three-dimensional crystalline solid of aluminum silicate. The chemical formula of zeolite is Na2Al2SiO208, used for drying of gases and pollution control. Let's proceed further. Types of adsorbent. There are different types of adsorbent. First, we classify adsorbent on a compounds that they contain oxygen containing compounds. They are hydrophilic and polar. Examples are zeolites and silica. The second one is carbon-based compounds, hydrophobic and non-polar. Activated carbon and graphite are the examples. Third one is polymer-based, may contain both polar or non-polar functional groups in a porous polymer matrix. Examples are polymers and resins. Types of adsorbent on the basis of pore size. There is another classification in which we classify adsorbent on the basis of the diameter of their pore size. There are three types: microporous, having pore size diameter in the range of 2 angstrom to 20 angstrom; mesoporous, having a pore size diameter in the range of 20 angstrom to 500 angstrom; macroporous, having a pore size diameter greater than 500 angstrom. Dear students, we have discussed the phenomena of adsorption. Let's have a quick review of the process once again. As in the definition, we said that adsorption is a mass transfer phenomena in which one substance is added or accumulate at the surface of another substance. The substance which is going to be added is called adsorbate, and the surface which is used for the adsorption is called adsorbent. Important terms in adsorption phenomena is adsorbate, adsorbent, desorption, absorption, and sorption. Principle of adsorption means why adsorption takes place. If it is a spontaneous phenomena, then there must be a logic that why adsorption occurs by itself. As we have discussed in physical classes, I have told you that surface of liquids or solid remain in a continuous strain or a state of unsaturation, which results in an unbalanced forces at their surfaces. These unbalanced forces results in higher surface energy, and this higher surface energy is responsible for the phenomenon of adsorption phenomena. Let's proceed further. Spontaneity and exothermicity. We have cleared it in physical classes from the Gibbs equation that delta G is equal to delta H minus delta Ts. Delta G is less than 0 means negative, and delta S is also less than 0 means negative. So the overall process is exothermic. Now, in the next slide, we have discussed types of adsorption, physical adsorption. If adsorption occurs due to weak intermolecular forces, or you can say that by van der Waals forces, then that type of adsorption is called physical. If there is an interaction of the adsorbent and adsorbate, the interaction between these two is because of the valence forces, means because of the covalent bond, ionic bond, or any type of chemical bond, then this type of adsorption is called chemical adsorption. Students, you must have a clear distinction between physical and chemical adsorption. There are few points which need to be considered, like physical adsorption is a reversible phenomena, while chemical adsorption is not a reversible phenomena. Physical adsorption occurs very quickly, while chemical adsorption requires some time. Positive adsorption, by positive adsorption we means that the concentration of adsorbate is greater on the surface of the adsorbent and less in the bulk volume, and the opposite of this is called negative adsorption. Now further factors affecting adsorption. Factor solubility inversely proportional to absorption. pH, as ionization depends on pH, and ionization also affects solubility. So pH and ionizations both are inversely proportional with the adsorption. Nature of adsorption: adsorbent, increased surface area will increase adsorption. Temperature, as adsorption is exothermic process, therefore increase in temperature will decrease adsorption. Next factor is pressure. Up to certain limit, pressure is directly proportional to the adsorption at a saturation pressure. Then the system becomes constant and no further adsorption will take place. Further factors are like concentration, amount absorbed, X upon M is equal to Kcn. C is the concentration, where K and N are constant and depends on the nature of both adsorbent and adsorbate. Commercial adsorbent: silica gel, activated alumina, activated carbon, polymers and resins, clay and zeolites. These are the examples of commercial adsorbents. Types of adsorbent: oxygen containing compound, carbon containing compound, polymer based. These are the examples: microporous, mesoporous, macroporous. Classification or types of adsorbent on the basis of pore size. And the last one is application of adsorption. Adsorption of noxious. First application is the adsorption of noxious. Noxious means harmful substances from the alimentary canal and use as an antidote. Activated charcoal, magnesium oxide and tannic acid when used orally reduce the toxic level of poisoning. Removal of toxic elements from blood through hemodialysis membrane over charcoal and adsorbent. Number third is adsorption phenomena is also used in chromatographic techniques, which is a separation technique. Number fourth application is microencapsulation of activated charcoal by acrylic hydrogel, prevents embolism and removal of platelets. Acrylic hydrogel is a biocompatible polymer, means it is compatible with the biological system and it will prevent embolism. Embolism, if something is moving in your blood, a clot, it may be a clot. Next thing is adsorption can affect the delivery of drug in the body, as drug containing antacid when given with other drugs. Example is like para-aminosalicylic acid and rifampicin, effect is reduced. If you will give a drug, concomitant delivery means you are giving two drugs at a time to the patient, that one contain antacid and the other does not contain antacid. So what will happen? The drug will adsorb at the surface of the other drug and it will inhibit the effect, or it will reduce the effect. So these were the application of the adsorption phenomena. And at the last, thank you very much, dear students. I will suggest you to go through the videos and make your lecture note. Hope it will be cleared. Thank you very much.